Welcome back to this series of Power Electronics Labs. Today we will go through Lab 7, PWM Circuit. The contents are 1. Introduction, 2. Circuit and principle, 3. Building prototype, 4. Testing results. Now let us start with the introduction. The purpose of this lab is to build and test a PWM circuit. The terminology PWM represents pulse width modulation. To form a PWM output signal VO, a common method is to compare two signals. 1. A triangle signal VT. 2. A reference signal VR. When the reference signal VR is higher than the triangle signal VT, the output VO is set to high. When the reference signal VR is lower than the triangle signal VT, the output VO is set to low. The frequency of the triangle signal determines the frequency of the output PWM signal. The voltage level of the reference signal determines the duty cycle of the output PWM signal. Now let's look at the circuit of the prototype and its working principle. A pre-designed integrated circuit TL494 is used in the prototype. It will output a PWM signal and control the two features. 1. Switching frequency, 2. Duty cycle. Here is the working principle of the prototype. To control the switching frequency, the RC circuit, C6 and pot 3 as shown in the diagram, forms a triangle signal. Adjusting the value of pot 3 will adjust the switching frequency. Another potentiometer, pot 2, is used as a voltage divider to provide a reference signal. Adjusting the value of pot 2 will adjust the PWM duty cycle. Now let's build the prototype. First, find the components for this lab. 1. The PCB portion, Lab 7 PWM circuit. 2. 2 pots, POT2, POT3, 10K. 3. 2 capacitors, C5, C6, 0.1 microfarads. 4. 2 resistors, R34, R35, 5.1K. 5. 1 DIP16 IC socket. 6. 1 IC, TL494. The recommended procedure for soldering the components are 1. Surface mount capacitors, C5, C6. 2. Surface mount resistors, R34, R35. 3. 2 through-hole potentiometers, pot 2, pot 3. 4. DIP16 IC socket. 5. Insert the IC into the socket. Now the prototype is completed. Now let's test the prototype and get the results. Here is the waveform of the output PWM signal. Use pot 2 to adjust PWM duty cycle. Use pot 3 to adjust switching frequency. Here is a video showing the adjustment of the output PWM signal. While adjusting the value of pot 2, the PWM duty cycle changes along. While adjusting the value of pot 3, the PWM frequency changes along. Now we complete the lab. Thanks for watching.